Hello everyone, and welcome to section 3.5, Solving Nonlinear Systems. You may remember that a system of equations simply means more than one. Okay, now when we did systems of equations before, both the systems were linear. Now we're going to have nonlinear systems, which means we'll have things like parabolas and lines, or maybe two parabolas. So this first one is going to be a parabola and a line. We're not going to graph it. We're just going to go ahead and solve it using substitution. When they're set as y is equal to, the easiest thing is to put x squared in for y. Okay, here we go. I'm going to say this a million times today. I see an x squared in my equation. What do? I set it equal to 0 and factor. Is this always going to work? No, but this needs to be your go-to. If you're still not good at factoring, just writing down what I write will not help you become better at it. Always stop at this step, hit pause just for a second, and make sure you can factor on your own. I cannot stress enough that factoring is probably the #1 skill that'll get you through the next couple years of math. Remember that it's first times the first makes the first, the last times the last make the last, and these inners, -2x, and these outers, which is 1x, always has to add up to the middle term, which is -x. So sometimes it's a little guess and check, but honestly, it's just the more you do it, the better you'll become at it. So x is equal to 2 and -1. Now don't stop there and box that answer. We're solving a system. So 2 and -1 are the x values for which this system has the same answer. But remember that this is some kind of a parabola in line. So I want to know the ordered pairs. I want to know the xy combination. So when x is 2, I can plug this back into either equation. So 2 squared is 4, or I could have plugged it in here. 2 plus 2 is 4. When x is -1, -1 squared is 1. Or I could have plugged it into here. -1 plus 2 is 1. That also confirms that it's correct if when you plug it in, it works the same for both equations. So all of these substitution methods are very straightforward. I cannot recommend enough that you try them on your own. I'm going to go ahead and write the answers. And when I'm done, you're welcome to just screenshot and try them all on your own, and then you only have to watch the video for the ones that you can't get. And last one. So go ahead and screenshot that if you want, give it a try, but I will be doing them all out. So again, the easiest thing to do is substitution method. This is y. So I'm going to put it right there where the y is. X plus 2 is equal to x squared plus x minus 2. I see an x squared in my equation. What do? I set it equal to 0 and factor. Now the minus x and the minus x actually make the x go away, but don't cancel these 2's too quickly. When you subtract 2 from both sides, this actually becomes a -4. At this point, you have two options. If you see that it's factorable, you're welcome to do that, and then you'll get x is equal to plus or minus 2. I have no problem with your saying, oh, but you said if there's no x term, that we could take the shortcut and do x squared is equal to 4, isolate the square term, and then take the square root, by all means. But don't forget that plus or minus, okay? Don't forget that plus or minus. I don't have room for both ways on my paper, so I'm going to leave it like this. And then don't forget this is not the answer. So when x is 2, I get 4. And when x is -2, -2 plus 2 is 0. I can try both those points in the other equation to verify my answer. But, you know, you can also just look in the back of the book at your homework and see if you got it right. Next one, substitution method again. I'm going to plug this in because this is equal to y. I can plug it in for y. Negative x plus 1 is equal to x squared minus 2x minus 5. I see an x squared in my equation. What do? I set it equal to 0 and factor. Adding x to both sides, subtracting 1 from both sides. This could be 6 and 1 or 2 and 3. I'm going to go with 3 and 2, which would give me 3x and 2x, which would make a negative x if the 3 is negative and the 2 is positive. So my two answers are 3 and negative 2. I'm not done. I'm looking for the answer to the system for the xy combination that works in both equations. This is definitely the easier one to plug it into. Negative 3 plus 1 is negative 2. And negative 2, okay, so this would mean the opposite of negative 2, which would actually give me positive 2 plus 1, which would be 3. If you're still just following along and not trying anything on your own, don't complain to me when you struggle to do these on your own. Okay, trying them on your own first and then watching the video is a great method. So I'm going to use substitution again. This is y, so x squared plus x minus 6 is equal to negative x squared minus x plus 6. When I bring this over, I get 2x squared plus 2x, and then minus 12 is equal to 0. That gives me, I'm going to take out the 2. X squared plus x minus 6. Ooh, this looks familiar. I just factored something really similar to this up here, except the x was negative. So how is that going to affect it? I'm still going to use 3 and 2, but now I want my inners to be positive 3x and my outers to be negative 2x to give me that positive 1x in the middle. So positive, negative. So that sign changed everything. Now I have 3 factors being equal to 0 all the time. Even seniors sometimes tell me the 3 answers are 0, negative 3, and 2, but this is not correct. Right? 2 is not the factor that's going to make that 0. But sometimes people just add a 0 when they see something on the outside. Don't do that. There's only 2 answers. X is equal to negative 3 or 2. So neither one of these are easy places to plug it in, but we can do it. So when I plug a negative 3 in, negative 3 squared is 9. I'm plugging into the first one. 9 minus 3 minus 6 comes out to be 0. So negative 3, 0. And then when you plug in the 2, I get negative 2, or 2 squared is 4, plus 2 minus 6 is also 0. So 2, 0. So I'm actually going to do the next one just a little bit differently. Some of you might want to say, well, can't we use combination? You can use combination. If you see it, if you think, oh, look at that, I can make the x's cancel, then that's great. So I'm going to add them together. So using combination, another choice. You don't have to use substitution just because the directions say to. In my class, you're always allowed to use any correct mathematical method. As long as it's valid, you can use it. So that gives me 2y is equal to the x's cancel, and I get 0. So y is equal to 0. So you'll see it didn't save you quite as much as you thought. So now I'm going to have to plug 0 into either one of the equations, and I still am going to have to factor. You thought you were going to get out of it. We're still going to factor. So x is equal to 1. So I only got one answer to this one, which means these two must just touch at that point instead of actually intersecting. They're both parabolas. So normally I would expect them to have 2 answers, but there's only one answer. So these 2 parabolas must somehow just barely touch. And the last one. Again, I'm going to show it to you by combination in case that appeals to you. So I would have to make one of them negative to cancel the y's. I can't cancel the x's because the x squareds cancel, but these x's don't. But if you really wanted to use combination, if you're wondering why we aren't doing it that way, we can do that. 0 is equal to 2x squared plus x minus 1. As you can see, I canceled the y's. It did not get me out of factoring, so it would have been just as easy to use substitution. But I'm just trying to give you choices in life. So I know it's going to be 1 and 1, so this is 1x and this is 2x, but I need it to be a positive x. So it's this 2x that I want to be positive and that 1 that I want to be negative. So this is 2x minus 1 is equal to 0, or x plus 1 is equal to 0. X is equal to 1/2, or x is equal to negative 1. Unfortunately, the 1/2 is not going to be pleasant to plug in. So I'm actually not going to use the y notation like I did over here, because see, I had to try and somehow indicate to anybody that might have been looking that I was plugging the negative 3 in. The correct notation for plugging a number in is this notation. Then you don't have to worry, do they understand what I'm trying to do? I'm definitely plugging a 1/2 in. So 1/2 squared plus 2 times 1/2 plus 1, which is 1/4 plus 1 plus 1, which is 2 1/4. So one of the answers is 1/2. It doesn't want to write quite that low to the ground here. So one of the answers is 1/2 comma 2 1/4, which I wrote up here as 9/4, same thing. And then the other answer, I plug in the negative 1, which is going to be much easier. Negative 1 squared plus 2 times negative 1 plus 1 is 1 minus 2 plus 1, which is 0. So the other answer is negative 1, 0. So in this next section, what they're saying to us is, can you match the graph? So just by looking at them, A is a parabola and a line. So I know it's going to be, can we kind of see them all? Yes, we can. Okay, so a parabola and a line. So I'm definitely looking at either this one, or this one. But this one and this one cross at 2, and I see that the y-intercept is 2. This one has a negative slope and doesn't cross at 2. So it's definitely not that one. So now I'm between these two. And the parabola is just x squared. It hasn't moved left, right, up, or down. So it's not this one. So this is this graph. And where does this graph look like it intersects? At 2, 4, and at negative 1, 1. And that is the answer we got for A. B is some kind of parabola also with the line x plus 2, which we've already figured out is this one. So now I know that this goes here. And let's see if our answer was correct. We said the answer was negative 2, 0 and 2, 4. Let's see if that's where these two intersect. 2, 4, it is. And negative 2, 0. So the point I'm trying to make is that when you're doing solving a system, what you're really finding are the points of intersection of that system. All right, see if you can match the rest of these up. This one so far was A, and this one was B. See if you can put a letter next to the rest of them. I will do them out, of course. So for C, I see that it's the third line, so I pretty much know it's this answer. But I want to make sure that I'm correct. For C, I did get the answers negative 2, 3, and 3, negative 2. Negative 2, 3, there it is. And 3, negative 2. So I feel really confident. But also this is a parabola with a negative slope line that passes through 1. All right, for D, 2 parabolas. One's going up, one's going down. One crosses at -6, and the other crosses at +6. Let's look for that. Oh, it's this one. See, look at that. That's crossing at 6 and -6, because notice they changed the scale for that one. So let's see if our answers are there. We said the answer to D was -30, check, and 20, check. So this one's definitely D. We only have 2 left, and we have 2 graphs left, so we should be able to find them pretty easily. They both have an up and down parabola, although these 2 parabolas cross at 1 and -1. So this one is going to be here. And notice that these just touch at 1 point, 1, 0, and that was what we got for this. So I hope you're really seeing systems of equations are represented by graphs, and the answers are the points of intersection. And of course, the last one is F. All right, F is important to me. This one is important because you will recall that this answer was 1/2 9/4. 1/2 9/4. Now that looks right. So I feel confident that my answer is right. But my big point is this shows you cannot always go backwards. Solving it algebraically is important because you can't always look at a graph and say, oh, it looks like it crosses at, yeah, these all crossed in nice places. But the graph doesn't always tell you exactly what you need to know. Let's actually do one of those now. It says, use the given graph of the functions to solve the system. So this one does look like it intersects at a very exact point. So if they say that, then you can go ahead and use the graph. Ooh, be careful of the value. Is it counting by? So in this direction, it's counting by ones. Watch your units. Your book loves to do this. So in this direction, it's -1, but it's 2, 4, 6, 8, 10. And then this one is 2, but also 10. But if you actually knew those 2 equations, then I would probably do it by hand to make sure that, for all you know, it's crossing at 1.9 and -9.9. It looks like it's 2, -10, but you can't be sure. And this one is what would happen if you had no solution. So remember that that's going to be an answer sometimes. Okay, so let's do these backwards. Let's not solve these algebraically. Let's solve these by graphing and see what we can find. It's mostly just a chance to practice our graphing skills. So this is a parabola that has not been moved left or right. It's only been moved up or down. So down 3, that's going to be my vertex. And I normally do 0, 0, 1, 1, 2, 4. But because of the 1/2, I'm going to multiply each of these things by 1/2. So this parabola, instead of going 1, 1, I'm going to go 1, 1/2. And instead of going 2, 4, I'm going to go 2, 2. So that's what that parabola looks like. This parabola is written in a funny way. So let's just change it. So now you can see it also hasn't been moved left or right. This is kind of like thinking about it like this. It's a +0. It hasn't gone left or right, but it's down 4. And I don't even need to graph it well. It's a negative parabola. No matter what it is, the answer is going to be no solution. But because we're practicing our graphing skills, I am going to graph it. So instead of 0, 0, 1, 1, 2, 4, I'm going to multiply by -2, which means if this is my 0, 0, I'm going to go 1, 2. And I can't do the 2, 8. But I want you to see it's a very skinny parabola. That was so bad. Very skinny parabola. Okay. The next one is a line and a parabola. Let's do the parabola first because I actually think the parabola is easier. So this is just a parabola that has been moved to the right 2 and then not up and down at all. From here, I don't even need to make my table because I don't need to adjust it. So 0, 0, 1, 1, 2, 4. How do you like that? Just like that parabola. The line is actually harder in this case. So you do know the slope is 1/4. All right, I hope you are listening to me. If you start at -1/2 and try and go up 1 over 4, if you miss a point that it's supposed to go through, I will mark it wrong. Just give me one good point. So change this to, not that one, change this to 2/4 and make this x minus 2 over 4. And then surely you can think of just one good point. How about 6, 1, right? 6 minus 2 is 4. 4 divided by 4 is 1. So 6, 1. Ooh, barely fit on there. Okay, what would be another one? -2. -2 minus 2 is -4. -1. There's one. -2, -1. I'm probably missing an easy one. 2. 2 minus 2 is 0. There's an easy one. 0. Okay, so -2, -1, 2, 0. This would give me a slope of 1/2, which isn't right. So somewhere I have made a mistake. Oh yeah, it doesn't definitely. Oh, 2, 0. I just plotted that point wrong. 2, 0. Not 0, 0. There we go. And so where does it touch? Right there at the 2, 0 that I plotted wrong. Thanks for being patient. And the last one. So this one is, can you tell that it's a line? Because it's x to the first power. It's a line that has been, instead of starting at 0, 0, I can go to the left 1 and down 3. And then it has a slope of 4. So up 4 over 1, up 4 over 1. Now, if you're not used to doing a line that way, you can multiply it out. 4x plus 4 minus 3, 4x plus 1. You could have started at 1 and gone up 4 and over 1. But remember that this thing is always going to be a point. So it's the point -1, -3, just like it is for all the other things that we learned. This one is a parabola that has not been moved left or right, but it has been moved down 2. So down 2, and then it has a negative out in front. So I still don't need to make a table. 1, 1, 1, 1, and then 2, 1, 2, 3, 4, and 2, 1, 2, 3, 4. So I go like that. And I can see that it crosses right there at -1, -3. So what people actually miss on this one is that it actually crosses again. So this line keeps going and the parabola keeps going, and eventually they are going to cross again. So the question is where? This is another reason why graphing is really not the best method. Algebra is. Algebra is awesome. So I'm going to use substitution method because I can't see it graphically. -x² minus 2 is, and I've already simplified that, so I'm going to use it, 4x plus 1. I see an x² in my equation. What do? I set it equal to 0. I'm going to move everything to the other side because I personally am better at factoring when my x² term is positive. So I get x plus 3 and x plus 1. and moved a little too far there. And so I know that x is -3 and -1. So I already found that -1 point. So I know that this one led to -1, -3. A little confusing because they both have a -3, but this is the x value. So what is the y value when x is -3? Well, you have two things you can plug it into. They should both produce the same answer. F of -3 for the line would give me -11. 4 times -3 plus 1. And f of -3 for the parabola. Now that negative is not part of the square. You're only squaring the x value and then doing negative. In PEMDAS, exponents come before subtraction. So you would square and then subtract. So I'm going to square and then subtract, which would give me -11 also. So this point that you can't see is -3, -11. So graphing clearly is not the best method. Okay. For that matter, going back, I wonder if this one hit again. So it could have just bounced off of it, but what if it ever so slightly went through it? Aha, let's go back and look. So I know you don't want to do this, do you? So again, doing it by algebra, x minus 2 squared is equal to, ooh, and this one has fractions. This one is definitely no good, but I think we need to know. So I am going to expand this. Watch out. I know, do you love all my little watch outs? It is not x squared minus 4. Bad. You have to actually multiply it out. X minus 2 times x minus 2. So I get x squared minus 4x plus 4 is equal to 1/4 x minus 1/2. This is a terrible problem, right? It's got a fraction in it. So clear the fraction. I will sell this to you all year long. Clear the fraction. You don't want to have to deal with it. So if it helps you, change this to 2/4 first. It'll help you clear it. So 4 times x squared is 4x squared minus 16x plus 16 is equal to, so 4 times 1/4 is cleared, so now it's just x. And 4 times 2/4 also clears the 4 on the bottom, and you just get 2. So I see an x squared in my equation. What do? I set it equal to 0 and factor. Whew, that is not going to be fun to factor, right? Actually, that's 18. I'm going to put it on the other side. So when I am struggling to factor, I always start with the numbers that are closest together. So 18 could be 1 and 18, 2 and 9, 3 and 6. I usually start with the 3 and the 6. And in this case, it doesn't matter which one goes where since the other sides are both 2's. That would give me 6x and 12x, which does not make 17. So that wasn't the perfect choice, but I'm going to go to my next choice, which is 2 and 9, which gives me 4 and 18, which also did not give me 17. Darn. Now, believe it or not, before I switched to 1 and 18, which is a little extreme, I actually usually change the other one instead. So while 2 and 2 is going to be the answer 90% of the time, sometimes it is 4 and 1. So 1x and 4x, and that's going to give me 9 and 8, which is 17. So as you can see, you're not always going to get it on your first try, but the more you practice factoring, the faster you'll become at it. And I'll try and give you every little tip and trick that I know. So my two answers are x is equal to 2, which we had gotten, remember? So 2, 0 was one of the points. But look, it does cross again. 4x minus 9 is equal to 0. 4x is equal to 9. X is equal to 9/4. Oh my goodness, what is that? 2¼ So right away, it crosses again at 2¼ And I'll just tell you that the other answer is 1/16. It's really close, and you might not have even seen it by graphing. So what is my point? Graphing is literally the worst method to use for solving. But I did these problems anyway because I wanted you to practice your graphing. I wanted you to practice your factoring, your solving, your clearing fractions. Every part of this was really still helpful. But for the rest of the problems, you are just going to solve by substitution. You are not required to make the graph to check them. So again, I'm going to go ahead and write the answers down. This first one especially. Whew, look at that answer. You might be thinking, no. So I can do that one with you. I'm going to do all of them. But on the outside chance that you would like to try some of them on your own, I'm going to put some answers up here for you. And number 3 is -2 and 16, -4, 0. You can screenshot that if you want. Number 4 is 4, 0. Number 5 is no solution. If you're doing these on your own and you don't show the work for number 5, you will not get full credit for these notes. You still have to show why that's the answer. So people that are working on your own, don't just look ahead at the answer and then try and work backwards. And number 7, but I would love for you to do as many of these as you can on your own. All right, are you ready? Another terrible answer. Algebra's tough. That's one answer, and the other answer is this. And I am going to go ahead and give you the very last answer. There's only one word problem today, -1 and -4. So for anybody that thinks they don't need to watch the video anymore, good luck with those. Okay, so I am going to go through them for you. So solve by substitution. I'll point out all the places people usually go wrong. So this is equal to y, so I can literally put that in there. X plus 4 is equal to x plus 2. I'm going to go ahead and expand this so I don't accidentally write x squared plus 4, which would be so bad. Plus 1. X plus 4 is equal to x squared plus 4x plus 4 plus 1. I see an x squared in my equation. What do? I set it equal to 0 and factor. Let's see, minus 3x. There's actually a 4 on both sides, so they cancel, plus 1. So unfortunately, this is not factorable. But we learned in another day how to get rid of, or how to solve a problem that is not factorable. We could complete the square, except that the middle term is odd, so I'm not going to choose that method. I am going to choose the quadratic formula, opposite of b plus or minus the square root of b squared. Oh, hold on, this is a plus 4, plus, so this is minus. B squared minus 4ac all over 2a, which turns out to be -3 plus or minus, plus isn't showing up good, square root of 5 over 2, which can't be reduced. All right, so where's the hard part for kids? The hard part is writing this, it's figuring out the y value, but it's really not as bad as it looks. So here's my first one. I do not know why I made such a big parenthesis. It does not need to be that big. And then my second one is going to be -3 minus the square root of 5 over 2. So I'm going to list them as separate answers. So to get the y value, you want to take -3 plus the square root of 5 over 2, and you want to add 4. The y value is just this plus 4. So give it a common denominator. Change the 4 to 8 over 2, and now you can add the numerators together. So the 8 and the negative 3 are going to make 5, all over 2. If this is the negative 1, right, plus or minus the square root of 5, then that didn't actually affect this answer. Negative 3 plus 8 is still going to be 5, but now it's minus the square root of 5 over 2. So your book wrote them combined like that, and you can do that as long as the plus goes with the plus and the minus goes with the minus. In your life, you might see this, minus 3 plus or minus the square root of 5, all over 2. And then if you ever see this, it's kind of a weird notation, but that would be because it's saying the plus goes with the minus. It doesn't in this case, but I'm just telling you for if you see it in the future. Okay, so where's the biggest mistake on this one? Right there. Don't make that. Somebody's still going to make that on the test. Don't do it. Okay, I'm more excited about this problem just because I can look ahead to the answer and be like, whew, that's not a terrible answer. Where's the mistake in this one? And keep pointing them out. Do not take the square root of both sides and write x plus y is equal to 4. Bad. Okay? Think about this. The square root of 25, we know is 5, right? Let's say I wrote it instead as 9 plus 16, because 9 plus 16 is 25, right? Does that mean you could take the square root of individual parts? The square root of 9 is 3. The square root of 16 is 4. Ooh, that's not right. The square root of 25 is not 7. Okay? Bad. Do not take the square root of individual terms. Okay? Cannot stress that enough. Okay, so now that we've gone over the most common mistake, let's actually do the problem. X squared plus negative x plus 4. Now, instead of writing squared, I'm just going to go ahead and write it out before we actually make the next most common mistake, which is to distribute the square. That gives me x squared. Negative x times negative x is positive x squared. The inners and the outers make minus 8x, and then plus 16. I see an x squared in my equation. What do? I set it equal to 0 and factor. So the 16s end up canceling, and sometimes people get really confused when there's no third term for factoring. But don't forget to factor out first. So factoring out is when I look at it and I say I can take a 2 out and an x out, and that leaves me with x minus 4. So my two answers are x is equal to 0 and x is equal to 4. I can plug those in pretty easily to either equation, but if I put it in here, negative 0 plus 4 is 4. And if I plug it into here, negative 4 plus 4 is 0. And I can check those, of course, really easily up there. 4 squared plus 0 squared is 16, and 0 squared plus 4 squared is equal to 16. Number 3. So I'm going to use substitution. No combination here is really going to work out for me. So I've already got the y. We'll do 2x squared plus 10x plus 48. So this is equal to y, so I'm going to put it right there. Is equal to negative 4x squared minus 16x minus 10x. I see an x squared in my equation. What do? I'm going to set it equal to 0 and factor. The 16x comes over, and that gives me 26x. And the 10x comes over. Can I do that all at once? Will that bother you, anybody? And that's actually going to give me plus 36x. And then there's no numbers to put together, so plus 48. These are some big numbers for factoring, so don't forget to factor out first. 6 comes out, and look at that. That's going to make that whole problem so much easier. Now my choices are just 1 and 8 or 2 and 4. And hopefully you can see pretty quickly that 2 and 4 are going to work out perfectly for making an inner of 6. Remember that this is not the factor that's making it equal to 0. So either 6 is equal to 0, or x plus 2 is equal to 0, or x plus 4 is equal to 0. So 0 is not one of the answers. Either x is equal to -2, or x is equal to -4. Neither one of these are pleasant to plug in. So I'm going to use the second one because it's just y is equal to. Y is equal to -4 times -2 squared minus 16 times -2. -2 squared is 4 times -4 is -16 plus 32 gives me 16. For my other one, I'm going to plug in my -4.
Mr. Nodine, please call the main office. Mr. Nodine, please call the main office. Thank you.
They did an announcement. I don't know if you could hear that in the background. So that gives me 16 times 4 is 64. 64 plus 64, this one's minus. -64 plus 64 is 0. And there are my two answers. The first step in the substitution method is always to get one variable all by itself. So I would probably make this into y is equal to, add the x to both sides, x minus 4. Then you can put that y right in here in this equation, rewriting it as x squared minus 7x plus 11 is equal to, and in place of the y, x minus 4 minus 1. I see an x squared in my equation. What do? I set it equal to 0 and factor. So minus 8x, when I bring that over, this is minus 5, so I'm going to add 5 to both sides. I get x minus 4 times x minus 4, and my only answer is x is equal to 4. When I plug that back in there, that leads me to 4, 0. Number 5. They're both equal to y, so I can literally put all of this, which is y, right in there. X squared minus 8x minus 19 is equal to 9x squared plus 6x plus 2. I see an x squared in my equation. What do? I set it equal to 0 and factor. So I subtract x squared from both sides. I add 8x to both sides. I add 19 to both sides. I see if I can factor out, which I can't. I think about factoring for a few minutes. 7 and 3 is really the best choice. Could be 8 and 2. That would give me 14 and 11. That's not going to work. It could be, it wouldn't be 8 and 2. 4 and 2, which would be 14 and 12, which still isn't going to work. It could be 2 and 4, which would be 28 and 6, which is not going to work. So how long you spend on factoring is up to you. It does help when you can see the answer. So I immediately move into quadratic formula. You could complete the square, but this is probably a little faster because there's an 8 out in front. And I didn't teach you how to do completing the square when there was an a. So negative b plus or minus the square root of b squared minus 4ac. So even without doing the actual math, I can see that this is going to be 14 squared, but this is going to be 16 times 21. This is definitely going to be bigger. And so I'm going to get a negative under the radical. So remember, this piece of it is called the discriminant. And when the discriminant is negative, that means you're going to have an imaginary answer. So the discriminant is negative. So the answer is imaginary. So where do these two parabolas intersect? They must not. They don't have any points in common because you're going to get an imaginary solution. What should you write for that? No solution. Number 6. Let's see, what variable can I get all by itself? I can get that y all by itself right there. So I'm going to move the x squared over. X squared minus 5x plus 29 is equal to y. And now I can put that right here. So I get x squared plus x squared minus 5x plus 29 is equal to 2x squared minus 1. So I made that substitution. That gives me 2x squared minus 5x plus 29 is equal to 2x squared minus 1. I see an x squared in my equation. What do? I set it equal to 0. Ooh, but look what happens. When I move the 2x squared to the other side, it actually goes away. And then I add 1 plus 30 is equal to 0. So setting everything equal to 0 is only for when you have an x squared or higher. When you just have an x, you actually want to isolate the x. So I'm going to move the 30 back to the other side and then divide both sides by -5. And I get x is equal to 6. My y value is right there. Y is going to be x squared 36 minus 5 times 6 plus 29. So 36 minus 30 is 6, and 6 plus 29 is 35. Remember to write your answer as an ordered pair, 635. Number 7. So again, I'm going to get y all by itself, or x, but it's easier because you only have to make one replacement if you get y by itself. So 4 minus x, which means that this will now be x squared plus x minus y. Now I need to warn you that this is a really easy mistake to make, not putting this in parentheses. It's minus the entire y. So if y is more than one thing, you're going to need those parentheses. This is a huge, I should write common error. So watch out for it. X squared plus x minus 4 plus x is equal to 1. I see an x squared in my equation. What do? I set it equal to 0 and factor. I bring the 1 over and, oh, this was a minus 1. I bring the 1 over and I'm going to get minus 3. I can factor that. The only choices for 3 are 3 and 1. I know that I need a 2x, a positive 2x, so I can get that if I make the 3 positive and the 1 negative. So in 1 negative, 3 positive equals 0. Keep writing this. Always have every single step match each other. So x is either equal to 1 or -3. Make sure you can't just write y is equal to, because you don't know if they line up. You have to write them as ordered pairs. So when x is equal to 1, y is 3. And when x is equal to -3, I'm plugging it back in here. 4 minus a -3 will actually give me 7. Hopefully you're getting the hang of these. Oh, that's ugly. All right, don't worry. We can do it. So it already has x is equal to. So it might be really tempting to put the x in here, but look why you don't want to do that. 9 minus y plus 2y plus 2, 9 minus y squared. Oop, that's an equal to sign. Not that we're going to do it this way. Plus 7 plus x. This is not worth it. This is terrible. So instead, you can rearrange this. I'm going to move the y over, right? Add y to both sides, and then move the x over, 9 minus x. This is going to be so much better. So you really got to think ahead. You got to use your head a little bit. We're going to make you awesome thinkers this year. So I have x plus 2 times y. So I'm going to put that 9 minus x right there where there used to be a y. equals 2x squared plus 7 plus x. I'm going to simplify it just a little bit. X plus 18 minus 2x is equal to 2x squared plus 7 plus x. I see an x squared in my equation. What do? I set it equal to 0. Are you so sick of this yet? I set it equal to 0 and factor. So these x's actually cancel, but I do have to move that 2x over. And I'm going to move the 18 over, which is going to give me a negative 11. I'm already not hopeful for factoring because this has to be 2 and 1, and the only choices are 11 and 1, which would make 11 and 2, which is 12 or 9. That's not going to work. Or 11 and 1, which would make 1 and 22, which also doesn't work. I need a 2 in the middle. So I immediately move to completing the square, but then I see I have an a. So even though this was even normally, but if this is a is 2, I go to a quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's see, what does that give me? So 8 times 11 is positive 88, plus the 4 is going to make that 92. So I think about the factors of 92 that might be perfect squares. So I make a list. 1, 4, 9, 16, 25, 36. I'm getting pretty high. Probably don't need to go higher than that. I look at a number like 92 and I think, well, probably 4 goes into it. So sure enough, 4 times 23. There could be a better one. So I might check to see if 16 goes into it or 36. But that actually is the best one. So we get x is equal to negative 2 plus or minus, and this becomes 2 square roots of 23. You might have heard me say before that I think the safest way to simplify is to do them separately. That way you make sure that you reduce correctly. There you go, you've gotten your x. Now remember, this looks ugly, but this is not quite as bad as it seems. So we're going to do this twice. When x is equal to negative 1/2 plus the square root of 23 over 4, y is equal to 9, it's a little hard to see that up there, 9 minus x. So 9 minus negative 1/2 plus the square root of 23 over 4. It's really not as bad as it looks because you can change that 9 to 18 halves. Now it becomes plus 1/2, and that becomes minus the square root of 23 over 4, which becomes 19 square root of 23, sorry, over 2. We reduced it. Let's fix that. 2. So 19 halves minus the square root of 23 over 2. So my first ordered pair answer, bringing those two together, is going to be negative 1/2 plus the square root of 23 over 2, comma 19 halves minus, do you see how that ended up happening? The plus ended up going with the minus because of the distributing of the negative. I'm just going to make myself a little room here, and I'll do the other one. So then the other one, that's the first answer. The second one, if x is equal to negative 1/2 minus the square root of 23 over 2, then y is 9 minus negative 1/2 minus the square root of 23 over 2, which again, you should change the 19 to 18 halves so that you have like denominators, and then you have to distribute that negative. So plus 1/2 and then plus the square root of 23 over 2. And so this answer, the x value, is negative 1/2 minus the square root of 23 over 2. And the y value is 19 halves plus the square root of 23 over 2. It's pretty hard. You're doing a great job. All right, everybody, last one. We are going to do the word problem application, which starts off by telling us that the sum of two numbers is -5. So let's just label our variables. X is equal to the first number, and y is equal to the second number. And it tells us that the sum of those two numbers, sum means add, is -5. And then it says the sum of the squares. So sum means to add, and here's the sum of the squares is 17. So I've done the first step. I've written a system of equations that represents the situation. Now I'm going to solve it. So back to substitution. X is equal to minus y minus 5. I'm going to put that right here. Minus y minus 5, the quantity squared. So be really careful. This is the biggest place where people get wrong. Minus 5 squared is not y squared plus 25. Okay, you do have to actually multiply it all the way out. It's a little bit of a pain, but it's the only way to get the right answer. So first, outer, inner, and last. Okay, one last time for the day. I see a y squared in my equation. What do? I set it equal to 0 and factor. So I could play around with this right now, but it'd be so much work because I've got big numbers like 2 and 10 and 8. Always factor out first. So I take out the 2, and then look at my numbers now. I only have to think about factors of 4, which is so much nicer. So normally, I think I would tell you that you should pick the numbers that are closest together. So 2 and 2 would be the best choice. But as you get better, you're going to be able to look ahead and say, but I need a 5. So it's definitely going to be 4 and 1. So y is either equal to -4 or -1. So plugging those in, when y is -4, x is opposite of -4 minus 5, which is -1. Or if y is -1, then x would be, I'm using this green equation up here, opposite of -1 minus 5, which would be -4. So if y is -1, x is -4. If y is -4, x is -1. Either way, the two numbers are -1 and -4. They have a sum of -5, and the sum of their squares, 1 squared, 4 squared is 16. The sum of their squares is 17, so you can check it pretty easily. So I did want to just point out one thing on the homework. You are not required to solve by the method and the directions. All year, for the next several years that you have me as your teacher, you're always allowed to choose the mathematical method of your choice. So if you can factor, factor. If you can complete the square and you like that, do that. If you want to use the quadratic formula every single time, you can do that. You may not finish your test on time because that's a longer process, but any mathematical formula you choose is okay as long as it's valid. All right, everybody, have a great day.